Dear students, in the previous class, we have seen that how to write the electronic configuration. We have written an example of sodium atomic number 11. Some more examples we can write. For example, potassium, scandium, atomic number 21. All these things we can just write it. See how to write the electronic configuration of potassium. Now you see, while writing the electronic configuration, the last subshell electronic configuration is coming after the D shell. I have told you before that it is because of the energy level. 3D energy and 4s energy. 4s is less energy than 3D. So it comes after 4s 3D writing. Okay. The next method or another way of writing the electronic configuration is, while writing the electronic configuration, we can use the inert gas electronic configuration. That is, for example, while writing electronic configuration of potassium atomic number 19, we can use the electronic configuration of argon atomic number 18 is an inert gas. So, while writing the electronic configuration up to 18, we can use as argon in brackets, then write the last one. That is, for potassium, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Then what it comes, 4s2 means it is 20, so 4s1. Then in that case, the argon atomic number 18 we can use, and after the bracket you can write that 4s1. See how it is writing.
The electronic configuration of potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. In this manner we can write. The electronic configuration of sodium also can be written in this manner. Please try to complete this table.
Now see, while writing the electronic configuration, two elements are peculiar, or we have to care while writing the electronic configuration of chromium and copper. Usually in exams, a question is a must. They will ask, write the electronic configuration of chromium or copper. What is the peculiar thing? That is, while writing electronic configuration, it ends in 4s2. In the case of chromium, that is atomic number 24. 3d4, 4s2, it comes. So for stability, one electron is donated by S subshell to the D. The same manner, in the case of copper also, one electron is donated to D to get stability. In the case of chromium, half filled is stable. In the case of copper, it is fully filled. That you have to remember while writing the electronic configuration of chromium and copper.
The electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Now one electron is donated to 3d orbit and becomes 4s1, 3d5. The atomic number of copper is 29. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Here also one electron is donated to d orbit and becomes 4s1, 3d10.
That is in the periodic table. While writing, there are, you know that 4 blocks are there, S, P, D and F. The first two groups comes to the S block, between center part comes to the D block, and the right side it goes to the P block, and the bottom side is F block. So while writing the electronic configuration, the last electron is filled in the block, or which subshell it belongs is the block of the element. For example, lithium, atomic number 3, electronic configuration is 1s2, 2s1. So the last electron comes to the s subshell, so it belongs to the s block. Look at another example. Now see the electronic configuration, or while writing the electronic configuration, which block it comes. That is the p block. The last electron, if it comes to the last subshell, it is p, it belongs to p block. And if it comes to the d letter or d subshell, it belongs to the d block.
Here the electronic configuration of carbon is 1s2, 2s2, 2p2. It belongs to the p block.
Now see, block we have find out. Now we have to see the period of the element, which period it belongs. So first write the electronic configuration, and the last subshell letter, it belongs to the period. Now we can find out the period of the element. So first write electronic configuration, then see the last subshell comes here, the number in the last subshell. That number is the period of the element. For example, in the case of lithium, or in the case of sodium, atomic number 11, while writing 1s2, 2s2, 2p6, 3s1, that the last electron comes to the 3s orbit or subshell, that 3 is the period. In the same manner, when we go to the higher element, higher atomic number, the same way you can follow, where the last electron filled up, that bigger number is belonging to the period. Now see the last part, that is group. Find out the group. Block we have seen, period, and last one is the group. So while knowing the block, period and group, we can find out the position, or we can isolate the position of the element in the periodic table. So how can we find out the group? If the element comes in the, or while writing the electronic configuration, the last subshell is belonging to S, there is no tension to write the group, because the number above the S letter is the group, if it is 1 or 2. Here S subshell can accommodate maximum 2, so it belongs either first group or in the second group. But in the case of P, if writing the electronic configuration and ending in P letter or P subshell, we have to add 12 to the number above the P letter, then only we get the group, because only after 12 column, 12 groups we jump, then only we reach the P block. So to find out the group of an element which belongs to P block, just add 12 to the number above the P letter. In the case of D, just you have to add, or you can add the number above the D and just left to the electronic configuration, or just add 2 to the number above the day subshell.